Hello, students. Welcome to video lesson 6-7. This is going to be our last video lesson for chapter 6. Okay, so we've been talking in this chapter a lot about polygons. We've been talking about specifically quadrilaterals a lot. How do we prove that something is a parallelogram, and what are the properties of parallelograms? And we talked about rhombuses and kites and rectangles and squares and trapezoids and all those special kind of four-sided shapes. And this is just going to be one extra application of that, but it's going to use a couple of formulas that we should be familiar with from previous courses or earlier in our geometry course, but we are going to just briefly review them and then apply them in a new way with all these special four-sided shapes and even triangles today. So this lesson is called Coordinate Geometry. It's going to use a lot of coordinate grid stuff. So if you do want to do your practice problems, they're all going to involve plotting points on a graph, not necessarily graphing equations, but plotting points certainly. So you may want to either print off for yourself some graph paper if you have any access to a printer or anything like that, or just be prepared that you're going to be making some coordinate grids in your homework, okay? Because I am going to want to see the points and not just the classification. All right, so that's a little helpful hint for you. If all I see in your homework is the classification of what shape it is, that's not going to be good enough. Okay, I'm going to want to see the graph and the points at least. So here's the three things that we're going to need to use. Okay, number one, we're going to have to use the distance formula. Okay, and the distance formula is basically how we find the length of a segment. Okay, now when we first learned the distance formula, we also learned it as, and I'm going to write up here, or the Pythagorean theorem. Oops, yeah, there we go. Okay, so the distance formula or the Pythagorean theorem is how we can find the length of a segment. And in our four-sided shapes, we're basically going to be finding lengths either of the sides or potentially of the diagonals, because remember a couple of our properties, specifically like about rectangles, it says the diagonals need to be congruent. So, you know, if we're going to try to determine if the diagonals are congruent, then we're going to be using the distance formula, okay? And I put the distance formula here for you, okay? X2 minus x1 squared, right? We subtract the x's, square them, and then we do the same with the y's, square them, add those together in square root. That'll give you the distance, the whole length, okay? The next thing that we're going to use is the midpoint formula. So the midpoint formula is how we find the midpoint of a segment. So what we can do is we can use the midpoint formula to determine if diagonals bisect each other, okay? So that's sort of the only way that we might have to use this one. This one won't be quite as common, but we might have to determine whether diagonals bisect each other, because remember, in a parallelogram, the two diagonals are supposed to cut each other in half. So we might have to find the midpoints of the diagonals and decide, are those at the same point? If the midpoints are the same, that implies that they bisect each other, the diagonals bisect each other. And then the third one is the slope. Okay, so the slope, that formula we learned back in Algebra 1, right? We subtract the y values, subtract the x values, make a fraction, right? And then, of course, we'll always reduce the fraction down. So it'll be equal to something over something, right? So we'll just call it like a over b for right now. So when we want to determine if lines are parallel or perpendicular, we are going to be using the slopes, okay, the slope formulas. Hopefully we remember that parallel lines means the same slope, right? Parallel lines mean the same slope. Perpendicular lines, hopefully we remember that those slopes need to be what we call opposite reciprocals, okay? Opposite reciprocals, okay? Opposite reciprocals. And just as a quick example, I'll scroll down here and give you guys an example. So that would mean like 2 over 3, and then negative 3 over 2, okay? So just right, so these two right here would be opposite reciprocals. 2 over 3, negative 3 over 2. Okay, so these are the three formulas or mathematical operations, I guess you could say, that we're going to have to use to determine how we classify the shapes that we're putting on graphs. Okay, so I haven't given you a ton of practice problems of this. I think maybe 5, and that's because each one is going to take a little bit of time. Okay, there's going to be some work involved here. We're going to have to sort of ask ourselves some questions. Okay, so if I look at this particular example here, okay, if I'm going to move these guys out of the way. So here's what you're going to be asked to do in your practice problems. You're going to be given 4 coordinate points or possibly 3 coordinate points and asked to say, okay, what is the most precise name for this? Like, how would we classify this? Is it a rhombus? Is it a rectangle? Is it maybe a square because it's both of those? Is it just a parallelogram, or is it not even a parallelogram? Okay, so one thing that we should note, if it is not a parallelogram, so like I say, step 2, is it a parallelogram? If no, we say it is a quadrilateral. Okay, so just keep that in the back of your mind. If it is not a parallelogram, and it's not maybe a trapezoid or a kite, okay, if it's just none of the fun stuff we've been looking at, we just call it a quadrilateral. Okay, it just means a 4-sided shape that doesn't have anything else special or specific about it. Okay, that's just a little hint. You might have to use quadrilateral as an answer in the end in your homework. So when we're given a question like this, the first thing that we're going to want to do is we're going to want to graph our 4 points. Okay, so step 1 is just a graph. So I'm going to take the 4 coordinate points that I'm given and I'm just going to put them on a graph. So I've done that here, and I don't know how well you guys can see necessarily my blue lines showing me my coordinate grids, but this is 3, 1 right here. Okay, this one right here is 3, 1. This one down here, well, I guess I'll go to the next one in this negative 2, 1. Negative 2, 1 is over here. Okay, negative 2, 1. And then down here, I think this is 4, 2. 1, 2, 3, 4, a negative 2. So that one there is 4, negative 2. And then this one over here is negative 1, negative 2. Negative 1, negative 2. Okay, so those are my 4 coordinate points. This is my 4-sided shape, and I'm being asked to determine what is the most precise name for this. Okay, so after we graph, step number 1, graph, now we're going to try to answer this question. Is it a parallelogram? Is it a parallelogram? Now, back in section 6.3, I believe it was, we looked at all the different ways that we had to determine if a shape was, in fact, a parallelogram. Okay, so we had the definition of a parallelogram, and that was the fact that both pairs of opposite sides are parallel to each other, right? So that would be one way I could answer yes if I can show maybe that this side is parallel to this one and that this side here is parallel to this one over here. Whoopsies. Just put that back there. Whoop. All right, so that's one option. Okay, the other option is to use some of our properties, okay, or some of our theorems to prove that this is or is not a parallelogram. I'll put those points back for those of you that are bothered by that. So we had, I believe it was 5 properties or converse properties to show that something was a parallelogram. So just some of those things to remind you. You can always go back in your notes, as I said, to section 6.3 to help you answer this question. But some of those things were, if we can prove that both pairs of opposite sides are congruent to each other, meaning the same length, that would prove that it's a parallelogram. If we could show that some of the angles were the same, that would prove that it's a parallelogram. If we could show that the diagonals cut each other in half, okay, that would prove that it's a parallelogram. All right. So there are a lot of different options. What I'm going to tell you is we're probably not going to deal with anything that deals with angles except for showing that something is a 90-degree angle, because 90-degree angles mean perpendicular. Okay, 90-degree angles mean perpendicular. So we talked a little bit about how we can use the slopes to answer that question. Now, it is okay for you to sort of get in your mind what you think maybe this shape is, and then try to use the math to show that, okay? Because we are graphing it ourselves, they should be drawn to scale depending on how good your graph is. Now, if your graph is sort of sloppy, then you can't just look at it and say, well, that doesn't really look like a parallelogram, so it's not one, okay? You are gonna have to justify it with some math. But let's talk through how we might do this. Step 2, is it a parallelogram in this particular case? I think the best way to do it in this case is either to use that special theorem that we had, which I'll put over here, special theorem which said one pair of sides that are parallel and congruent to each other. Okay, so if I have one pair of opposite sides, okay, top and bottom or left and right or whatever, that are parallel to each other and the same length, then I can say yes to this question over here, is it a parallelogram? All right. Now, in this particular picture, I want you to look and I want you to determine in your mind which of these sides are easiest to show that they are parallel. Well, it's this one on the top and this one on the bottom. Why? Because they're both horizontal, right? They both go right along the coordinate line, right? They go right in a horizontal line. So I don't really even need to see you find the slopes of those lines to convince me that they are parallel, okay? So what I'm going to say for this part of my answer, is it a parallelogram? I'm going to say top and bottom. Whoops, that's supposed to be an O. Top and bottom are horizontal. Okay, top and bottom are horizontal. So that right there tells me that they are parallel. Okay, so that gives me one pair of opposite sides that are parallel. So top and bottom are horizontal, so that means they're parallel. Then if I can prove that those same sides are the same length, congruent to each other, I will have this part of this property or this theorem to prove it's a parallelogram, okay? So the top and bottom are horizontal. Are they also the same length? Well, here's the wonderful news about proving these are congruent to each other or the same length. I don't actually have to use the distance formula. Remember, up top I had said we're going to use the distance formula to determine if sides are congruent. The exception to that is unless they, are horizontal or vertical. Okay, if the lines are horizontal or vertical, you don't have to use the distance formula. Why? Because I can just count the squares, and that gives me the length of that side. Now, it does not always, like for example, this side length here, this is not, I cannot count squares going 1, 2, 3 like that. Okay, I can't do that when it's not horizontal or vertical, but I can do that when it is horizontal or vertical. So here, I'm just going to count from here, and I'm going to count 1, 2, 3, 4, 5 squares. So that length right there is 5. Okay, so that's 5. And then if I do the same thing on the bottom, I go from here and I count 1, 2, 3, 4, 5. That one's also 5. And I have proven that they're congruent because they have the same length. Okay, so then the other part of my answer is just going to say top and bottom are horizontal and both 5 units. Okay, top and bottom are horizontal and they're both 5 units. So have I proven that it is a parallelogram? Yes. Yes. Okay, now, is that the only way to prove that this shape over here is a parallelogram? No, the other one that makes the most sense to me is if you use these diagonals and you prove that they have the same midpoint. Okay, so if you're pretty okay with doing the midpoint formula, where you would do, in this case, like -2 plus 4 divided by 2, and 1 plus -2 divided by 2, you could find the midpoint, okay, it'd be right here. And then you do the same thing with these 2 points, find the midpoint of those as well. If they have the same midpoint, then it's absolutely a parallelogram, okay? So I've proven it's a parallelogram. Now the next question is, what more specific shape do I think this might be, okay? So I'm gonna erase some of this stuff. I'm gonna erase maybe my counting here. I don't need this 5 anymore. And I don't need my counting along these lines anymore. So I'm going to try to prove maybe that this thing is maybe a rhombus. Do we think it's a rectangle? I would say hopefully we don't think it's a rectangle, because these are not 90-degree angles, right? If I have a horizontal line here, this would need to be a vertical line to be perpendicular, right? A horizontal and a vertical make a 90-degree angle. Because this side's not vertical, then this is not a 90-degree angle, right? So it's not going to be a rectangle. I know that. So I'm going to just go ahead and cross out the idea of this thing being a rectangle. Nope. So that also means it's not going to be a square, right? Now, because I just proved it's a parallelogram and I said yes here, it's not a trapezoid and it's not a kite either. So my only other question is this thing a rhombus? Well, in order to show that it's a rhombus, what would we need to show? What would we need to show? Well, we had some ways to do this. Most of the properties of a rhombus were about angles, okay? And it said that the diagonals, 2 things have to be true. They have to cut these corner angles in half, and they have to meet each other at a 90-degree angle, okay? They have to meet at a 90-degree angle. The other thing is they have to, well, if it's going to be a rhombus, not so much the diagonals, but all 4 sides have to be the same, right? That's the definition of a rhombus. So there's sort of 2 options, and I'm going to do it both ways for you real fast. Number 1 option is sides congruent. Like, are these sides congruent to each other? Like all 4 of them? And number 2, are the diagonals perpendicular? Diagonals perpendicular. Remember, our symbol for that is just the upside down T. Are the diagonals perpendicular? Okay, so in order to prove the sides are congruent, I'm just going to pick any 2 random sides that I don't maybe think are congruent, okay? So I can show maybe that they're not. So I know this top side here is 5, right? I know that's 5. So the question is, what is this side length over here, okay? And this is where, because it's not a horizontal or vertical, we are going to have to use the distance formula. Okay, we're going to have to use the distance formula for this. Or we can use the Pythagorean theorem. So if we don't want to use the distance formula, and we want to use the Pythagorean theorem, which is sort of my preference, I prefer to use the Pythagorean theorem instead, I can just drop this down, right, and slide that over and make this little tiny right triangle here, which I'll maybe draw over here then for myself as well. So I end up with a little right triangle that looks like this. And I'm trying to find this side length right here and to see if that is 5, just like the top side is 5, okay? So the only thing I have to determine is, well, how far up and down is it from this corner point to this corner point? Well, it goes from 1 in the y direction to -2 in the y direction. So how far is that from 1 down to -2? Well, that's a grand total of 3 squares, or 3 units. So that side's going to be 3, okay? And then this one, how far is it left and right? Well, it goes from -2 in the x to -1 in the x. How far apart are those, -2 to -1? Well, that's just 1. So I have these sides, and I can use the Pythagorean theorem to go 3 squared plus 1 squared equals this unknown value squared. I'll say x squared. Okay, so 3 squared is 9, 1 squared is 1, so this ends up being 10. 10 equals x squared. So what is x? What is the square root of 10? Well, here's the good news for you guys. I don't actually care what the square root of 10 is. Do I? I really don't. I don't care what the square root of 10 is because I'm just comparing this to what other side? I'm comparing it to this one up here. So my only question is the square root of 10 equal to 5? Square root of 10 equal to 5? Nope. The square root of 25 is equal to 5, but this doesn't say the square root of 25. It says the square root of 10. So is the square root of 10 the same as 5? No. Are these sides congruent? No. Okay, the sides are not congruent, which means, is this thing a rhombus? No, it's not. Okay, now I'm going to show you how you would find that also using the slopes. If you prefer the slope formulas, doing your y minuses and your x minuses, to doing the Pythagorean theorem or distance formula. Okay, so we should all be on the same page that the answer is going to be no, but I'm going to use are these diagonals congruent, and I'm going to try to figure out if that is the case. So diagonals, not diagonals congruent, trying to figure out if they're perpendicular. So I'm going to first work on this diagonal here. Okay, so I'm going to write down these two coordinate points. I'm going to write down -2, 1, and 4, -2, because those are the coordinate points. Make sure that's a negative. Those are the corner points for this diagonal here, top left to bottom right. So I'm going to use the slope formula to figure out, okay, what is the slope of this line? Okay, so remember that we subtract the y values and put that on the top. We subtract the x values and put that on the bottom. So in this case, my slope formula is going to say, I'll just go this way, -2 minus 1, right? -2 is this y value and a 1 is this y value, so I minus those. Then I have 4 minus -2, because that's this x value and this x value. So I think I end up with -3 over 6. Okay, -3 over 6. So that's the slope, which I could reduce to -1/2, but I'm not going to worry about it yet. That's the slope for this diagonal here. Okay, now I'm going to do the same thing for this other diagonal, right? And I'll see if I think those slopes are opposite reciprocals. Okay, I am going to say this one equals -1/2. And what you can be thinking about, you guys, is what am I looking for now in my perpendicular slope, right? What do I want it to be if it is going to be perpendicular? Well, remember, perpendicular slopes do flipped over reciprocal and change the sign. So we would go from -1/2 to +2/1. So that's what I'm going to be looking for when I do this other diagonal. Okay, so I'm going to erase these guys, and I'm going to put my other coordinate points here instead, and I'm going to see what those slopes end up being. So the other two corners, the coordinate points are -1, -2, and 3, 1. So I'm going to see what the slope is for those two lines. All right, let's see what the slope is. So if I write down those coordinate points, -1, -2, and 3, 1, I'm going to try to find the slope between those 2 points. So again, I'm going to do the same thing, do my y minuses. I'm going to do, in this case, 1 minus -2 over 3 minus -1. Okay, I did 1 minus -2. Oops, sorry, it's supposed to be a comma there. And 3 minus -1. All right, now I'm going to figure out what does that equal. Well, 1 minus -2, that's 3, right, because it turns to ++. And then 3 minus -1 also turns to ++, and that ends up being 4. So one of my slopes is 3/4, right? And the other one is -1/2. So the question is, are those opposite reciprocals? Are those perpendicular slopes? The answer is absolutely no. Okay, no, they're not. So is this a rhombus? No, it's not. All right. So I want you to understand that this is me going sort of slowly through this whole process, but now I'm ready to give my answer. Okay, remember the question was asking, what is the most precise name for the quadrilateral with vertices, blah, blah, blah. And what did we determine? Did we determine that it was or was not a parallelogram? Okay, it was. So now the only other question is it a rhombus? No. Is it a rectangle? No. Is it a square? No. So what would we say? Our final answer is this quadrilateral is a parallelogram. So I'm going to say parallelogram. That's my final answer. Okay? So that's what one type of problem looks like. The other thing I'm asking you to do just in maybe 1 or 2 problems is to do something like this. So more distance formula and Pythagorean theorem. I'm not going to go totally through this one, but I do want to remind everybody, hopefully we remember what isosceles triangles are. Okay, isosceles triangles means 2 sides the same. 2 sides congruent. Equilateral, remember, means all 3 sides congruent. And then scalene means none. Okay, if all the sides are different. So when you're asked this question, you're going to have to take these coordinate points and find what is the distance of this side length right here. What is the distance of this side length right here? What is the distance of this side length right here? 3 times, and then go ahead and tell me what you think that triangle would be called. Okay? If you have questions, please reach out to me. I know these problems are kind of a lot of work, so if you get stuck with, Mr. Frederick, what am I supposed to do next? Just a second, Rudy. My dog wants to go out, so I apologize for that. But quiet, Rudy. But if you have questions about what's the next step, what am I trying to do here, please reach out to me. I'm going to be available as much as I can here shortly in the next couple days after my new daughter sort of gets settled here. But otherwise, if you don't have questions, you should be prepared now to answer these questions, and we will talk with you soon.